y equals 4x squared over x minus 3. We better do the division, hadn't we? So I'll give myself some room here to do the division. 4x squared over x minus 3. So how many times does x minus 3 go into 4x squared? So let's have a look at that then. Dominant term is x, so that goes in 4x number of times, doesn't it? Multiply through 4x squared, and then minus 12x, isn't it? Take them away, one from the other. This take that disappears. Nothing, take away minus 12x is positive 12x. Then we now ask ourselves the same question, but how many of these goes into this? Well, it goes in 12 times, doesn't it? Because we then get the 12x when we multiply through, and we get minus 36. Take them away from one another. This disappears and we get 36 underneath. So it goes in 4x plus 12 number of times with the remainder of 36. So we can write that 4x plus 12. And then the remainder was 36 over the x minus 3. So this is what we have. So we notice now then that this value, when x gets large, this value here gets really, really small. So this value here, when x gets large, positive or negative, this value gets small, so it approximates to the line here, 4x plus 12. So I'm going to put in the intercept here, and I'm going to draw a line with a positive gradient, but I'm going to scale it in such a way that it's not drawn too steeply. So this is of gradient 4. So what have we got then? That's the first thing to say. It approaches this line. As x gets large positive, this will be a large positive underneath, won't it? Making this small positive, this fraction. So, but it's added, so it'll be approached from above, won't it? So it's going to come from here and go like so, towards this line from above. As x gets large negative, this number underneath here is large negative, making the fraction small negative, isn't it? So it's going to approach this value just underneath, small negative underneath. So it's going to come down like so to this line here. So that's what we've got there. Now the other area of interest is when x equals the value 3, which I'll mark off here on the scale. And we're going to need to put in an asymptote here. And it looks like we want to confirm from looking at it that it's going to shoot up to infinity here and shoot down to infinity here, like so. When does it equal 0? We could put that in straight away. It equals 0 at 0. Doesn't it? When you put x as 0 in, you get y equals 0. So that goes there. So it's going to shoot, it might be the maximum here, and then it might turn, the maximum might be before, and it might be after. I'm going to probably, for the purposes of this sketch, I'm going to probably draw it around 0, like so. Now I just need to confirm that it goes up and down on this side and this side. So 3.1, if we put that in here, this value is just a normal number, but if I put 3.1 in, say here, this will be a small positive, making the fraction large positive, so it is going to shoot up to infinity. And if we put 2.9 in here, this will be small negative, making the fraction large negative. So it will shoot down to here on this side. So the sketch is going to come, so I'm going to draw it now. Oops. And I'm going to draw a sketch over here. So let's have a go. So it's going to come down from here, turn and go along to there, and it's going to come up from here, turn, I don't know, around 0, and then tend towards this line here. So a smoother curve, obviously. We could work out the maximum if we did differentiation, but it looks like it's too painstaking a prospect for the purposes of just drawing a sketch. So this will suffice then, and now we can label our graph. Y equals 4x plus x squared over x minus 3. Now let's confirm it with our little tool. So we want to type in 4x squared. I'll just type it in here in this small dialog box. Doesn't matter that you can't see it, of course. I'll just type it in. X minus 3 from minus 10 to 10. So let's see what we get. Yeah, it does look like the maximum's here at 0, or thereabouts. Comes up from this asymptote at 3. And you can see the straight line coming along here. The scaling is done so that the 4x line isn't quite so steep, just as we've done in our sketch here.